Imagine a drug so powerful that just a tiny dose can bring immense relief or cause instant tragedy. Fentanyl, one of the most potent opioids in the world, has revolutionized pain management, but has also fueled a devastating overdose crisis. Today, we'll explore the dual nature of fentanyl, its life-saving medical applications, and its devastating role in the opioid crisis. First, a brief history of fentanyl. It's a synthetic opioid, meaning it is chemically synthesized rather than derived from opium poppies, like natural opioids such as morphine and codeine. However, it is up to 100 times stronger than morphine and 50 times stronger than heroin. Fentanyl's history began in 1959, when it was first synthesized by Dr. Paul Janssen, a Belgian pharmacologist who sought a potent and fast-acting pain reliever for surgical procedures. Initially introduced under the brand name Sublimaze in the 1960s, fentanyl became widely used as an anesthetic in operating rooms. By the 1980s and 1990s, its applications expanded significantly with the development of new delivery systems, such as transdermal patches and lozenges. These innovations provided new solutions for managing pain, solidifying fentanyl's role as an essential drug in modern medicine. However, the early 2000s marked a turning point, as illicitly manufactured fentanyl began infiltrating drug markets. Criminals exploited its high potency and ease of production to create counterfeit pills and mixed it with other drugs. By mid-2010, fentanyl had become a central figure in the opioid crisis, driving an alarming rise in overdose deaths. Chemically, fentanyl is a synthetic opioid that belongs to the phenylpiperidine class of synthetic opioids. Its chemical name is N112-phenylethyl-4, piperidinal N-phenylpropanamide. Quite a mouthful. Its structure is characterized by a phenyl ring connected to a piperidine ring, with an aniline group and a propionamide functional group. These features are essential for its high affinity to mu-opioid receptors. The phenyl ring contributes to its lipophilicity, aiding in rapid absorption and facilitating its passage across the blood-brain barrier, resulting in a fast onset. Fentanyl's structural features give it an affinity for mu-opioid receptors that is approximately 50 to 100 times greater than that of morphine. Its stability allows for various methods of administration, including transdermal, injections, and oral formulations. Modifications to its structure have led to analogues with varying potency and pharmacokinetics, such as sufentanil and remifentanil. Fentanyl works by binding to specific receptors known as mu-opioid receptors. This binding triggers a conformational change in the receptor, inhibiting the release of neurotransmitters like GABA and enhancing dopamine release. The result is profound analgesia and a euphoric effect. This powerful effect makes the compound highly addictive. With repeated use, individuals develop tolerance, requiring increasingly larger doses to achieve the same effects. However, fentanyl's high lipophilicity and extreme potency not only make it effective, but also incredibly dangerous. Even a few milligrams can suppress respiratory function, potentially causing a fatal overdose. A lethal dose of fentanyl is significantly smaller than that of heroin. Lethal doses vary based on factors such as method of ingestion, purity, body weight, and individual tolerance. However, in most cases, as little as 2 milligrams can be fatal. In controlled medical settings, fentanyl is used in several forms, including intravenous injections, transdermal patches, and lozenges. Its lipid solubility allows for rapid absorption and penetration across the blood-brain barrier, leading to a fast onset of action. This makes it particularly useful in managing post-surgical pain and chronic pain in cancer patients. The drug's efficacy and rapid onset make it a preferred choice for severe pain when other opioids may be insufficient. Despite its medical benefits, fentanyl has become a central figure in the opioid crisis. Illicitly manufactured fentanyl began appearing in the early 2000s. Today, fentanyl is a leading cause of opioid overdose deaths worldwide. In the United States, synthetic opioids, primarily fentanyl, were involved in nearly 70,000 overdose deaths in 2022, accounting for approximately two-thirds of all U.S. drug overdose deaths. Illicit fentanyl is often mixed, laced, with other substances such as heroin, cocaine, or methamphetamine, or pressed into counterfeit pills that resemble prescription medications. This increases the risk of unintentional overdose, as users may not be aware of the presence or concentration of fentanyl. Small variations in mixing can result in lethal doses, highlighting the dangers of its misuse. The high lipid solubility also contributes to its rapid and overwhelming effects, making it particularly deadly in overdose scenarios. Efforts to combat the fentanyl crisis include naloxone, a synthetic opioid antagonist capable of reversing overdoses. Naloxone is an opioid antagonist that competes with opioids for mu-opioid receptors in the central nervous system. Due to its higher receptor affinity, naloxone displaces opioids like fentanyl, reversing their effects without activating the receptor. However, since naloxone's effects last only about 90 minutes and fentanyl is highly potent, multiple doses may be required. The dual nature of fentanyl as both a critical medical tool and a public health challenge has spurred research into safer alternatives for pain management and more effective treatments for opioid addiction. Scientists are developing new compounds that offer pain relief with a lower risk of addiction or respiratory depression. Fentanyl exemplifies the immense power of modern pharmacology, showcasing both its potential for healing and its devastating risks. Its unique chemical structure and mechanisms of action have made it an essential medical tool, yet it remains a significant public health concern. Through scientific innovation and public health efforts, we can mitigate the dangers posed by fentanyl while preserving its value as a medical resource. As always, thank you for watching. If you have any video ideas, comment them below, and we'll see you in the next video.